Yeah, today we'll start with the Verilog HDL. Okay, we have completed digital logic design and CMOS design. So there we left with the static timing analysis. Static timing analysis we'll discuss at the end of the course. And today we'll start with the Verilog HDL. Okay, so what are the main contents of the course for Verilog? What we are going to cover, the main things is introduction to the Verilog. That means the evaluation of Verilog. Okay, what is the difference between Verilog and VHDL? Why Verilog is very suitable for the hardware description language? And introduction to the EDA tools. Morning, I have shared the tools to install in your laptop, right? I have shared the YouTube link. So if anyone not installed those tools, you can try again. Okay, if you install or if you have some other tools, you can use those tools. Okay, so if you face any doubts in the tools, you can ping me. And also we are going to discuss data types, operators. Okay, the basic things. We will start Verilog from basic to advanced, right? So all types of description styles, that mean how many types, in how many ways we can write the Verilog programming. Okay, different description styles. And RTL design coding, RTL design and verification. Okay, Verilog is used for verification also, right? Not a high level, but test benches we can create using the Verilog. Okay, but not suitable for the high level, in the sense like complex projects or complex architecture, we cannot use the Verilog, but we need to learn the test bench also. And modeling of sequential logic circuits and combinational logic circuits, registers, counters, how to model different types of registers and different types of counters. Finite state missions. Okay, different ways to write the finite state missions. Memories like FIFO memories, RAM, ROM. And coming to the protocol, we are going to give either UART protocol or APB protocol, any one protocol. And the project. Okay, last 2 days we are going to discuss about the protocol and the project and interview questions. Okay, so these 5 days schedule. So first, today we are going to discuss introduction to the Verilog and introduction to the EDA tool. I already shared the YouTube video of EDA tool. I think you got, everyone got clarity from that, right? Have you seen everyone?
Yes, ma'am.
Everyone install? Have any doubts there? Okay, and we are going to discuss about the data types today and operators and description styles, how to write the Verilog program simply, and verification concept. That means how to write the test bench. Okay, these things maximum we'll cover. If we left anything, tomorrow we can discuss. And tomorrow is for combinational logic circuit, blocking and non-blocking assignment, those things. And Wednesday is for sequential logic circuit, and Thursday is for finite state mission and the memories, and Friday is the protocol and the project explanation. Okay, Saturday we'll take on static timing analysis. If we don't have time for protocol and project, we'll extend one day. Okay, so these are the things Verilog we are going to discuss in these 5 to 6 days. Okay, so first we'll start with the introduction to the Verilog HDL. Can you tell me, any one of you, why we are using Verilog HDL? Why Verilog HDL is mostly preferred than VHDL? Um, yeah. Can anyone?
Uh, yes, ma'am. VHDL is very complex as a code to write, whereas Verilog is easy and it just takes less time compared to VHDL to execute the program.
Okay.
It
Okay, we
supports
have,
so
yeah,
many
tell.
modeling like gate level modeling, switch level modeling, all this, and behavior
Okay.
level modeling.
Yeah. So we have different types of languages like assembly level language and all, right? Those languages are not described or not used to describe the hardware. That means here everything we are developing for the hardware, digital logic design for digital circuits, right? So that's why Verilog is mostly preferred. Verilog has structurized to design these digital logic circuits. Okay, in Verilog we have both the analog Verilog and the digital Verilog. Analog Verilog is used for the analog circuits where we use the diodes, transistors, and analog components. For that, analog Verilog can be used. And but here we are using everything in the digital gates, flip flops, registers. All these are in digital, right? So here we are preferring the Verilog HDL for hardware modeling. Okay, whereas C language, C++ or Java or these things cannot use it to design the hardware because those syntaxes should not allow to describe these things. Okay, because if you want to store any data, we need to use register, and also for sequential logic circuit we need to generate the clock. Okay, these all are things involved like a hardware modeling. That's why Verilog language is only preferred to describe all the things. And VHDL also, VHDL is also one of the hardware description language, but compared to the VHDL, most of the industries using Verilog HDL because VHDL is a very complex language. Okay, to implement or to learn, it is very complex language. Okay, different standard libraries all involved in it. Okay, we need to use standard library if you use different type of logical operations. If you use arithmetic and logical operations or mathematical operations, we need to use the standard library according to that. Okay, and coding wise also it is a very complex. It takes more number of lines compared to the Verilog. That's why Verilog is very simple language, easy to implement. Okay, and also easy to learn. Okay, just like a C language. That's why Verilog is mostly preferred in everywhere in every VLSI industry. Okay, VHDL is very less. Okay, that's why in this course we are going to learn the Verilog HDL. Overall things of both the RTL designing and also test bench. Okay, mostly you need to focus on the RTL design side because Verilog is mostly used for designing. If you go for verification, we have some other languages, high level languages like System Verilog and UVM methodology like that. So that's why concentrate more on design part by using the Verilog HDL. Okay, so
Ma'am, what's the difference between system Verilog and Verilog, ma'am?
yeah, system Verilog is for verification. Okay, suppose by using the Verilog also we can write the test bench. Why we need to write the test bench means first of all you will write the design, right? We'll discuss. I will tell you later that thing. Yeah, first getting
Ma'am,
started with the tell.
ma'am, so we use test bench basically for waveform verification and we use the design part. So why are we using system Verilog, ma'am? Like, what's the difference,
Yes,
ma'am?
yes.
Like,
Wait,
we
just
can write.
wait. I will tell. Yeah, wait. I will tell by end of the session. Just let me complete few topics, okay? Then you will understand why we use the system Verilog and all, okay? So why do we use Verilog first of all? As I told that Verilog is mainly for the hardware description language. Okay, mainly the purpose of Verilog, it is able to generate the different type of digital components like registers or wires or gate or clock. Mainly for synthesizing purpose, it is very best language. That's why Verilog is mostly preferred. Okay, up to here, everyone concept clear, right? For everyone. So while running, it will take some time. So yeah, compiling, analysis and synthesis. Here we need to take a netlist viewer, RTL viewer, register transfer. Okay. So here if you see, this is the full adder circuit diagram. Based upon our code, we have generated the circuit netlist. So what we are calling this. First of all, can you tell me what is the difference between synthesis and simulation? What is the difference between
Uh,
synthesis and simulation?
Ma'am, synthesis is basically version of the logic RTL code we have written into an hardware language, or sorry, the conversion of the language we have written into gates form, while simulation is basically providing the inputs and observing the waveform. Ma'am.
Okay, any other answers?
Yes, ma'am. So, ma'am, before synthesis, we basically do simulation so that to verify our design by applying several test benches on that, and after the completion of that synthesis, then we can simulation. Then we can easily synthesize. So, in during synthesization, we do not need any type of test benches.
Okay, so synthesis is nothing but generating the circuit netlist. Okay, generating the circuit netlist or RTL. Okay, so for that purpose, what we are doing based upon the CAD tools, okay, whatever the EDA tools we have or CAD tools we have, CAD tools in the sense circuit aided tools we have. Okay, so we are writing one Verilog module, we are writing the program, and we are taking that program into the tool. Whatever I did here, I'm writing the program for the full adder here. So by using this program, I have generated the circuit netlist. Okay, this process is nothing but synthesis. This process is nothing but synthesis, whereas simulation is nothing but another thing. If you observe here, what they have mentioned here, synthesis means they have mentioned like they are dumping the program into the ASIC and the FPGA. What it is mean, after generating the circuit diagram, whatever the circuit diagram we got here, it is a full adder, means very simple thing. But if you go to the very complex architecture, okay, that architecture we can dump into the FPGA, which is a ready-made chip. Okay, by using that FPGA, we can treat that FPGA board as that particular functionality. Suppose traffic light controller is there, you can dump the traffic light controller into the FPGA. You know the FPGA, right? I think you have done some IoT projects by using the Arduino and all. In the Arduino, you did some of the projects based on automatic automation things and all, right? Like that, the same FPGA also it is a ready-made chip. You can dump our program into the FPGA, and you can connect some small suppose traffic light controller means we'll have LED bulbs, small bulbs, so you can take a yellow color, green color, red color, and based upon your Verilog programming, you can observe these things like that. Home automation, like a fan on, bulb on automatically based on your Verilog programming. Okay, whatever the design is generating here, that design we are dumping into the FPGA chips or the ASIC chips. ASIC chips means permanent chips, which are used for the for manufacturing of processors and all. ASIC, we already discussed the difference, right? ASIC and FPGA. So once we whatever the Verilog programming we have taken, after doing the synthesis, that program, that circuit netlist can be dumped into either ASIC or FPGA. This process is nothing but synthesis. This process is nothing but synthesis. Just we are generating the circuit from the program. Okay. So once you generate the circuit according to your program, we don't know whether this circuit is working correctly or not. Right? We don't know whether these outputs are generating correctly or not according to your inputs. So for that purpose, what we are doing, we are applying the inputs to the design. Okay, this is our design for the ABC. We are applying 0 0 0 0 0 0 1 0 1 0 like that. By applying the inputs, these will generate some output, right? So that is nothing but verification, that is nothing but stimulus. Okay, that is nothing but simulation. We are applying a stimulus to the design inputs and checking the output, that is nothing but simulation. Okay, everyone got that? How we are applying the inputs means based upon the test bench. We are creating the test bench and we are applying the inputs to the design, and we are verifying the output. That is nothing but simulation. Everyone got the difference between synthesis and simulation?
Ma'am, so synthesis is basically we are
Please join for
converting.
the next session. Everyone, please join for the next session quickly.
Ma'am, so what's the difference between verification and
Verification. Simulation is nothing but verification.
okay, ma'am.
Simulation is nothing but verification, right? Simulation means we'll talk the word we use in the Verilog. Verification means some high level for system Verilog UVM. There will use like verification. Both are same. Okay.
Ma'am, can you please repeat that FPGA part of synthesis?
FPGA.
Yes, ma'am, FPGA part, you were telling that we have to put the circuit in the FPGA.
Yeah.
But
So
after
you
that,
know, yeah. You know, in VLSI we have two types of chips, right? One is a ASIC chip, one is a FPGA chip. So whatever we are using IC, I'm telling our processor, right? Every digital circuit, if you take at least a watch or alarm or laptop, mobile phone, or any type of digital gadget, if you take every circuit, they have internally chip. One chip will be there. Even your ATM card also, there will be one small chip will be there, right? Those all nothing but digital ICs, digital chips, digital processors we can call. Okay, those are nothing but permanent chips. So whatever we are using in our laptop processors are there, those are permanent chips. Permanent chips in the sense, once we dump the program, we cannot reprogram it again and again. Suppose if any processor damage, we cannot do anything for processor damage. We just throw out, right? So those types of chips are nothing but ASIC chips. So how we will manufacture the ASIC chips? We have entire VLSI design flow, right? Designing first specification, taking the specification, writing the RTL design, verification, physical design, floor planning, routing, timing evaluation. All these things are there, right? So to manufacture the ASIC chips, we need to follow all these things, which are permanent chips. Okay, those we are calling as a application specific integrated circuit, nothing but ASIC. Whereas FPGA, I'm telling as it is a ready-made chip. Okay, FPGA means you already worked on different IoT projects as you are under graduation, right? You may work on Arduino. Okay, like IoT, like it is like a Raspberry Pi. For embedded systems, we'll use Raspberry Pi, which is wait, I will show why we need to. Wait, I will show in net.
So, ma'am, the Arduino is like ASIC or FPGA type.
See, this is the FPGA. Suppose if you see here, this is the FPGA chip, same as like a Arduino. Okay, so we have different series of FPGA will be there. Okay, by using this FPGA, we can develop small projects even in the companies also. Whenever they are taking some processor, okay, they want to get some processor into the market, right? So that processor cannot be dumped, that program cannot be dumped directly into the ASIC chip. That means silicon wafer. They won't directly dump into the silicon, because if any error occur, the material everything will be wasted, right? So first they will dump their hardware design into the FPGA, then they will check all the outputs are getting correctly or not by using the FPGA. Then only they will manufacture the original ASIC chip. Okay, so like that FPGAs or like a ready-made chip can be used for the projects or any circuit development or any for functionality, like that. We can reprogram it again and again, many number of. So if you see here, some LCD display is there, like that you can use for traffic controller, like a digital watch, like that you can do so many projects. So these are two VLSI chips we have. One is a ASIC, another one is a FPGA. Okay. You can also search as a ASIC chip. ASIC chip in the sense you will get these are permanent processors. See, these are the main permanent processor, nothing but integrated circuits, right? So these are the ASIC chips. Okay, so these are the ASIC chips. There is a difference, right? If you observe between FPGA and ASIC, there is a difference, right?
So, ma'am, while designing ASIC chips, can we prototype it on the FPGAs all and then we design the ASIC chip?
Yes, yes. First, we can check functionality with the FPGA, whether they are working fine or not. Then we can move to the ASIC. We can dump into the permanent chip. I will share you that one video, YouTube video, how actually processors are manufactured. So you will get one idea. Okay, I will share that video after the session so that you will get the idea. Okay, so everyone clear what is the difference between synthesis and the simulation? Everyone?
Yes, ma'am.
Okay. Now we'll see how to write the program. Suppose if you see here, we have generated for the full adder, right? So what is the full adder here? So can you tell me what is the need of data type for any language, for C language or C++ or Verilog or System Verilog? So what is the need of data type?
To define the white task, what type of inputs we are using.
Okay, to define what type of the data we are taking, like whether it is negative type or positive data or any character type or like integer type or bit type or byte type. Okay, so these different data types to determine any variable in like whatever the particular value we are going to store, to determine that thing we are using the data types. Okay, so in Verilog we have only two type of data types. Only two type of data types we have in Verilog. One is a net data type, another one is a register data type. Okay, one is a net data type, another one is the register data type. In net data type we have while, W or, W and. Okay, so W or, while, W and or the net data types. Okay, so you know already what is the use of wire data type. So whenever we want to use the connections between one gate to another, so suppose here output of one gate to given to the input of another gate, right? So here this variable will be declared as a wire data type. Okay, then for combinational logic circuits, okay, if you want to design a combinational logic circuits, for those things also you can declare the input and output as a wire data type. Okay, so wire means it doesn't store any value. It doesn't store any value. Okay, for the combinational logic circuit, we'll design wire data type. We'll take wire data type. Okay, and so this is the circuit, this is the program. If you see module, name of the module is the example, and here the port list A, B, C, D, Z, out is the port list. So what are the inputs and what are the outputs? We have taken that thing here, no need to take Z. So 4 inputs, 1 output, and wire is the internal variables like internal connections. So what is the value here? Assign X equal to A and B. X is nothing but output of A and B. Y is equal to output of C or D. Okay, assign out equal to A, X or Y. A or X or Y. Okay, so whatever the two outputs here we are getting, so two outputs is given to the one OR gate. So this is the output. So which type of modeling this is? Can anyone tell? behavioral or data flow or gate level?
Ma'am, data flow.
Data.
Data flow. Why?
Data flow.
Because all are expressions, right? So everything we have written in terms of expression. This is also expression. This is also expression. All the things are expressions. If you write like and, name of the AND gate is A1. So what are the inputs? X is the output, comma A, comma B. So A, comma B are the inputs, and OR gate. So OR name is O1. Like that you can take. So Y is the output, C, comma D, comma input, and out is the next another OR gate or O2. What out is the output, and X, comma Y are the inputs. If you write, this is the gate level modeling. Okay, so like this you can design the program any model. Okay, you can design and you can do synthesis and the simulation. Okay, that is about the wire data type. Wire data type is nothing but it is mainly used for the combinational logic circuit. It doesn't store any value. Okay, next W and WR. W and WR also same. It is mainly used for the combinational logic circuit. It doesn't store any value. Okay, so here how we have written, suppose the ABCD are the inputs, W and W are automatically taken as wire and the W and the Z. That means if you see Y equal to A XOR B, and again Y equal to C and D. If you don't use any W and here, if you put directly output, it will generate two different AND gate, here XOR gate and the AND gate. But here we taken and W and as a Y. That's why for Y automatically it will generate a AND gate. Okay, no need to write separate code. It will automatically it will assign to the Y. Okay, so if you see here what happens, we have written for one circuit, we have written 3 number of statements, right? So here X and Y are different wire internal variable we have taken. But here in this example, we have taken just a W and just declared Y as a W, and so automatically it will place with the AND gate. Okay, next one also same. Z equal to E or F. Here also Z equal to not G. So Z means W or. So automatically one OR gate will be generated for the particular. We'll see quarters prime how it
Excuse me,
will
ma'am.
generate.
Excuse me, ma'am.
Yes, sir.
Ma'am, we can use W and W are only for two input gates, or we can use it for multiple inputs as well, ma'am.
Multiple inputs we can use. Not only for two gates, multiple inputs you can use. Any gate we can use the multiple times.
So let's suppose if there was one more XOR gate with E and F as inputs, ma'am. So we could directly use W and
Yeah,
Y.
for
And
demultiplexers, we have for demultiplexers, we'll have multiple gates, multiple inputs, and one output, right? For that also we can use.
Ma'am, so if we have like if in the example you took right now, so if we have one more gate which is XOR gate, we can assign the value of Y to it, and then we can directly use W and W or like that.
Yeah, we can use.
Okay. Ma'am, so it's basically we are just replacing it, replacing the wire variable and AND gate with W and or WR. It's something like that only.
Replacing means not replacing, just if you want to generate some AND gate for two different variable with where we can take like this, for that you can do. Like for same variable, we can generate the AND gate or OR gate simply like this.
How to change the model.
Module name. Have you tried everyone with a quarters prime? No, here it is not taking. It's to W and W, or if you have any Xilinx tool like that, just try with the W and W, or this tool is not accepting this W and W, or
Ma'am, Vivado accepts, I think.
Vivado. Okay, just try in Vivado whether it is getting or not. If you get that circuit diagram same like this, just ping in the group how you get the output. Okay.
Okay.
Okay, so WR and WN we can use for that purpose. So these are the three data types in the net type. And coming to the register data type, in register data type, we have synthesizable and non-synthesizable. Okay, can you tell me what is the difference between synthesizable and non-synthesizable?
Ma'am, synthesizable, we can convert it into a hardware model now, while non-synthesizable cannot be synthesized. We can't generate its netlist.
Yes,
Yeah,
ma'am. So we
synthesizable.
only use synthesizable to write the test benches.
Okay, synthesizable is nothing but which generates the RTL design. Okay, nothing but synthesis. Non-synthesizable is nothing but which is a test bench. Test bench is the non-synthesizable. So if you see here, reg data type is used for both design and the test bench. We can use both in the design and the test bench. Okay, so reg data type will store the data. It will store the values. Okay, reg data type store the value, whereas var data type doesn't store the value. And reg data type is like a register, nothing but sequential logic circuits. Okay, for the sequential logic circuit, whenever you are using sequential to declare the output, we will use the reg data type or the register data types. Okay, so mainly reg data type is reg A, reg B, reg X. Okay, you can define the size. Okay, whether it is a scalar quantity or it is a vector. Vector means you can define the size, whether 4-bit size or 8-bit size, 16-bit size, like that. Okay, based on that, it will store the value. If you take the scalar, scalar is nothing but 1-bit variable. So directly you can put like a reg A, reg B, like that. That is the scalar. Okay. Next, coming to the non-synthesizable data types, or integer, time, real. Okay, these three we will use only in the test bench: integer, time, real. So if you see here, I have taken integer, time, real variables, three variables, integer A, real B, time C. What is the A here? 32-bit value. Okay, whatever the 32-bit value is there, that thing we have defined. So 32-bit tick hexa. H means hexa and some value. That means each value will be generated for 4 bits. Okay, and B equal to some decimal value. Okay, floating value. In C language, we'll call float, right? Like that in Verilog, we will call as a real. Okay, like that C equal to dollar time. Dollar time is the system task. So here it define the time. So at 20 time units, we define the time here, right? At 20 time equal to some value. So this time is defined by the dollar time. So these three are the data types can be used for the simulation. Okay, now we'll do this. I will check the output. What is the output here? These are the related to the test bench. So when you are writing the test bench, you need to follow these things. Okay, try to learn to write how to write the test bench. Test bench is also very important. So I'm copying the code here. So we'll see. I will tell you how to use the EDA playground also. This is the best tool for doing the synthesis simulation. You can do using model simulator also. If you're facing like model simulator is complex, means you can use the EDA playground also. Okay, how you will use? Okay, see what are the errors we are getting? Test bench 8th line. Okay, error debugging also very important. You need to learn that thing also. So here we did mistake and here quotation marks need to keep like this.
I mean, in eighth line, the letter A.
Yeah, where 8th line letter A. A is nothing but hexadecimal, right? We can take A, B, C, D, any value. So if you see here, what is the output? A equal to some minus value is getting some minus value. But what value we have taken? A equal to 32-bit hexadecimal some value. Okay, if you want to generate same value, what we need to do? These are the format specifiers we are calling. Okay, so what is this percentile D? Percentile D is nothing but integer value. Okay, it will define the integer value. So we have converted this hexadecimal into the decimal value. That's why we are getting this type of value. If you want to get same value, you can put a percentile H. You can print in the hexadecimal. Okay, and if you see here B equal to 0 point something, that also we are printing in decimal only. That's why it is giving 0. It is not giving in a real value. Okay, and 20 time units, 20 time is a decimal only, right? So 20 is giving correctly only. Okay, and another thing, if you observe A equal to something here, B equal to taking this much of distance and C is equal to taking this much of distance. So if you want to print all the values in the order, you can change, you can put the width here. Okay, you can put print all the values in the same line. So we'll change these things. So first thing is I want to print in hexadecimal. So H. Second one is a real. To print the real number, we will use a G. I already told you binary means B, hexadecimal H, octal O, decimal D, and a real number G. Hierarchical way also we can display hierarchically also. Hierarchically means M. I think hierarchically means M. So next here integer is the 20 like D. D means we can print it directly. So if you want to remove this here with this gap, what I can do means I can put the bit here like 0 bit 0. 0 means very minimum. If you want to put some more 5 like that, you can put. Okay, if you want to display the string name means percentile S. Okay, like that hierarchical name is not W, it's yeah, M. I told M, right? Yeah, M. So if you want to display time means T. In place of D, I can put the T. Okay, see here, all the variables we got in a same line, right? So the distance is very minimum. If you want to take more distance, in place of 0, I am putting 5 so that you will get more distance. Okay, see first 2 I have changed. You can observe.
Ma'am, is time a data type in Verilog, ma'am?
Data typing?
Is time a data type in Verilog?
Yes,
like 6th line we have defined time C.
time C. In system Verilog will define C, yeah, but in Verilog will define T only.
No, in sixth line, ma'am.
In sixth line, time C, yeah, that is just a variable we have taken. C in the sense just a variable, time is a data type. In place of C, if you don't want to take directly, you can change dollar time. Directly you can display the dollar time.
Can I
Okay,
take
we'll
wire
see
C? Can I take
Wire
wire
C.
C?
Wire
Yes.
C, if you take wire C, this time particularly for this value, it doesn't show the time. Then you need to use here. Wait, I will tell you. Suppose in place of C, I am taking as a 0 value, and here I am taking as a while. Okay, so if you want to print time C, here if you want to print time, I'm making dollar time here in the display statement. Okay, dollar time C equal to something, so it will print the value now. It will print at 20 time units, C equal to 0. So what is the value? Yeah, so wire we cannot take the value because it is synthesizable, right? If you are connecting with the design, then we can take the wire, because these are the procedural assignments. We have some rules out there. Okay, for procedural assignments, left hand side variables must be declared with the rich data type only. Okay, that's why we are taking C as a rich, because C is the input here. That's why. Okay, so if you see, if you observe, what is the thing here? C is the 20 time unit. At 20 time unit, it printed equal to 0. Okay, 20 is the time, as we mentioned dollar time here. Okay, clear everyone? Everyone clear? Integer, real, and time data
Ma'am,
types.
what does dollar time does, ma'am?
Dollar time is nothing but system task. Now we are going to discuss the verification concepts also. I will tell you clearly. Everyone understood about integer, real, and time here?
Ma'am, why do we use dollar sign this?
Dollar?
Ma'am, why do we use dollar sign matlab, in front of every like display?
Dollar sign is these are the system task. Okay, sign, the dollar represents these are the simulator directives. For the simulation purpose, we are using these different system task. That is just representation of that system task. Okay.
No, ma'am. Ma'am, can you
Okay.
please explain that reg 7 to 0b? Like we're just creating an array or something like that, ma'am.
Yeah, it will print a value of 7-bit data. Okay, I will show you here in EDA. Suppose here I'm C in the sense I'm taking 4-bit size. 4-bit size in the sense 3 down to 0. 3 down to 0 means you can assign some between 3 down to 0. That means 2 power 4, right? 2 power 4 means up to 14, 16 number of combinations we can assign. Suppose I'm assigning here the value 15. Okay, C equal to 15. C equal to time, right? It will represent okay, I'm putting 0 D. Okay, time also nothing but same value it will represent. Okay, C equal to 15. Within the range means C equal to 15. But if I am assigning C equal to 40, but 40 is not within the range of that size, right? So it will print some other value. C equal to 8, because size is not match. Suppose if I take size, more size, 10-bit size I am taking, then it will give correct value.
So ma'am, the
Okay,
size
C
is
equal
only
to
till,
40.
ma'am, so it will only support
Yes.
till 2 power the number of bits. we
Sorry,
are
Alex.
using.
Yes. Same as whatever the bit size we are taking, it will take accordingly. Those many combinations we can store. Okay, here in Verilog, we have the we can call this as a static array. Static array means at the declaration time only we will use this we'll take fixed size value, right? But if you move to the system Verilog, there we have static array, dynamic array, associative arrays. Okay, dynamic array means if any size is not sufficient. Suppose here we are facing this problem, right? Initially we have taken as a 4-bit size. If size is not sufficient, again we are changing at the initialization time only. But in system Verilog, we no need to change like that. We can resize the array. That resize concept is nothing but dynamic array. Like that, we have associative array also. Associative array in the sense we no need to mention any size. Okay, just we can mention like a star or something. If you mention like a star C, okay, automatically it will take some size. Initially it won't take some size. Actually it do the functionality, then it allocate the size to that particular variable. Then we no need to face any problem whether it is sufficient, the size is sufficient or not. Like that, we no need to face any problem. Okay, so that is a associative array, dynamic array, those concepts in Verilog. But in system Verilog, but in Verilog we don't have those things. That's why Verilog is not mostly preferred for the verification. Okay, if you move to the system Verilog, you will learn lot of things like this. Okay, any doubts?